construction of Bode plot. I have already taught you a problem. Okay. So here also we are going to see one more problem with one more poles over here. So how the equation should be in the form of the denominator? It should be in the form of 1 plus s into t. First you have to check whether it is in this form. If suppose it was like this, 2 plus 3s. Okay, in the same here, in place of here, that is 10 divided by s into 2 plus 3s into 3 plus 6s. If it is like this. Okay, what you have to do, you have to make this into 1. 1 plus, you have to make this in the form of 1 plus s. So what you will be doing, you will be solving this 10 divided by s into, if you take this 2 common outside, what happens? It will become 1. 1 plus, here it will be 3 by 2s. And here if I take it 3 common outside, it will become 1 plus, here it is 6 by 3 into s, which is, it will be 2s. So it becomes a 2 into 1 plus 3 by 2 is 1.5. 1.5, yes, here this is this. Okay, and here 3 into 1 plus 2s. This should be in this form. That is like 1 plus s into t. Okay, likewise here 1 plus s into t. It should be in this form. If the question was not like that, means what you have to solve accordingly. Okay, here in our question there is no need to solve this particular calculation. It was straightly given, that is 10 divided by s into 1 plus 0.4s into 1 plus 0.1s. Okay, and what you have to do, first you have to replace the s with j omega. So the first step 1, you have to replace the s with what? J omega, that is in terms of frequency. So frequency response, we will be drawing two plots with respect to log of omega. Frequency, what is the, we will be calculating magnitude with respect to. Likewise, the frequency plot, log of omega with respect to what we will be calculating for phase angle. Okay, these two graphs we are going to be drawing by doing this calculation. Okay, so for here we will be using what graph? We will be using the semi-log graph sheets. Okay, and after now going to the problem, s is equal to j omega. First, what will becomes g of j omega is equal to 10 divided by, in place of s, that is j omega into 1 plus 0.4 j omega into 1 plus 0.1 j omega. Okay, and now next what we have to do? Next we have to identify the terms. Next we have to find out the corner frequencies. Okay, so what is the formula to find out the corner frequency? Go to the first problem which I have taught you. WC1 is equal to
1 by.
So first write down, that is terms. Okay, next we will be finding out the corner frequency. Next what we will be doing? We will be finding out the slope. Next we will be finding out the change in slope. This is the procedure tablet we need to find out. First, the term. What is the term here? Here it is 10 by j omega is the first term. That is 10 divided by j omega. What is the remaining term? If I have taken 10 to j omega here, it will become 1, right? So the second term is 1 divided by 1 plus 0.4 j omega. What is the third term? 1 divided by 1 plus 0.1 j omega. So here 10 divided by j omega is here. Is there any t term? Is there any time t? We know that omega is equal to what? Omega is first we know that omega is equal to 2 pi into f. So I can say that it is 2 pi, frequency is reciprocal of time. So I can say that omega is proportional to reciprocal of time. Okay, so here j omega is here. There is no term called time here. Okay, so there won't be any corner frequency for the constant terms. Next term be further s plus t. It will be like this. Okay, 1 plus ts. Here there is corner frequency. we need to find out that. What is that? Omega C1. What is the omega C1?
1 divided by 0.1.
1 divided by, why it is 1 divided by? Omega is equal to what? 1 by time t. So omega C1 is equal to, here it is 1 by, what is the time here? 0.4. So it is 1 divided by 0.4, which is equal to what?
2.5.
2.5. What is the unit of omega? It is radian per second. Okay, next thing is omega, take it as common frequency 2, omega C2. So it is 1 divided by 0.1, which is 10 radian per second. Clear up to this? Next, what you have to find out? Slope. To find out the slope, what you have to know? If it is S. S is replaced by j omega. Then the slope will be plus 20. Okay, if it is 1 by S, it will be like 1 by j omega. It will be minus 20. This is the prediction you are going to do. If suppose, based on this, if it is S square. Okay, how it will be? It will become
40.
plus 40. If it is 1 by S square, it will become minus 40. That is how we will be identifying the slope. So now, so for the first case, it is 10 by j omega. Then what is the slope here? Minus 20. Here, 1 by j omega, it's a denominator of the j omega. It will be also minus 20. And here is also j omega is in the denominator, so it will be minus 20. How will we be doing the change in slope? We will be adding this two. That is minus 20 minus 20 is equal to what? Minus 40. Again, we have found some slope over here, change in slope. We will be adding the change in slope with the next slope. That is minus 40 minus 20, which is equal to minus 60. This is how we will be doing the change in slope. Now, by this diagram, I know that omega C1 is equal to what? 2.5 radian per second. And omega C2, what I know? Omega C2 is equal to, I found that it is 10 radian per second. Okay. Now, I have to predict what? The lower frequency and the higher frequency. So, I am going for the lower frequency, what it will be. And what will be the higher frequency for the clocks. Okay, so lower frequency should be less than 2.5. Okay, so if you take 1, what it will happen? We will be finding out the log of k, right? Log of 1, it will become 0. Okay, so don't take the lower frequency as 1. Okay, you can take it as 0.1. Less than 2.5 means you will be assuming it as 1 or 1. If you are assuming it will become log of 1 will become 0. So don't assume lower frequency as 1. Okay, just assume it as 0.1. Okay, so lower frequency is assumed to be what? 0.1 radian per second. What is higher frequency should be? The higher frequency should be greater than this 10 radian per second. You can take it as 20 or 50 or 100. For our calculation, 100 will be easy. So I am taking it as 100 radian per second. Clear? Next, what you have to find out? You have to find out the value of A. Okay, that is then omega is equal to omega L, lower frequency. What is the formula to find out the value of A? A is equal to A is what? Magnitude. First, you have to remember that. Okay, I have taught you the theory, that is A plus J into B. This is the form where A is the magnitude and J is the angle of j omega. It will be like this. This is magnitude of g of j omega plus angle of g of j omega. Or we can, in total, we can say that magnitude of j omega is we have to draw derive a derivation for it. Okay. So for that, what we have to draw? Finding out the magnitude. That is in place of a, what we have. So when omega is equal to omega L, what is the formula? Up to where you have to remember that means where the omega C1 stop. Up to there you will be applying this formula. That is A is equal to what? 20 into log of what it is? Is j omega or
frequency value.
20 into log of, check it out and say. In the previous problem, the finding of the omega is equal to omega L. What is the formula?
Lower frequency value.
Omega L.
Omega
Okay.
L.
1 minute, not omega L. Check it out. See, there in previous problem, the numerator term contains s square. Okay, so the formula is a into log of that s square, which is the j omega square. J square will become minus, so we will be putting minus 20 log of omega square. That is why there it is omega. Okay, here what is our constant here term? That is first term is when for I am assuming omega is equal to omega, the term is 10 by j omega. So the formula is 20 into log of, if you the our problem is 10 by j omega. That is 10 by omega. Okay, so if we substitute that is a is equal to 20 log of. What how it will be? 10 by omega. What is omega? Omega L is 0.1. 0.1. Finally, tell me what is the answer for A. It will be around 40. Did you get the answer?
40.
40. So it is 40. We will be marking it in decimal since it is magnitude. Clear? I am saying it once again. The formula is magnitude A is equal to 20 log of. What is our problem's term? There in previous problem, the problem's term is s square. So we are replaced with s with j omega. So it becomes j omega square. So if I substitute j omega square, j square will become minus. So I have to put a minus in the front. Minus 20 log of omega square there. This 20 log will follow the same. Okay. So here in this problem, 20 log of our term. What is the term here? 10 by j omega. So our term should be written as 10 by omega. Okay. So what is our omega? 0.1. 10 by 0.1. Which will be 40 decimal. Clear? Next, when omega is equal to C1 crossing frequency. What is the first crossing frequency? It is 2.5 radian per second. Okay. So under this condition, what is the gain formula? A is equal to C. Here is also there is no change in slope. Change in slope starts from where? Omega C1 to omega C2. Here only the change in slope starting. So till that, how you will be finding the A using this formula. Okay, you have to note down where is the change in slope starts. The formula will change from there. Okay, I will tell you here. So here there is no changes over here. So next, what you will be doing? A is equal to the same formula. 20 log of 10 by what is our omega?
2.5.
0.5. So 2.5, which is what is the answer?
12.04.
Okay, which is 12. That is plus 12 dB. Okay, and now you have noticed that there is a change in slope. We are doing this change in slope here. From the omega C1 to we are going with, listen, from omega C1 to we are going with omega C2. If this change in happens means formula will be of what for magnitude means A is equal to slope changes from where? Slope from omega C1 to
C2.
omega C2 into log of omega C2 divided by omega C1 plus A at the previous term omega C1. Here this is the formula. Where you have to note it down where this change in slope comes. That is the change in slope to the next slope where we are going to minus. There the formula changes like this for magnitude. Till then we will be finding it in 20 log of term. First term. After that the formula changes to A into slope from where we are changing omega C1 to omega C2. Into becomes log of omega C2 divided by omega C1 plus A at the previous stage. A at the previous stage. A and omega C1 is what? 12. Then we will be substituting the 12. Okay. And now what is the value for when omega is equal to? Okay, we will be finding for A. For value what? Omega is equal to omega C2 is equal to how much? 10 radian per second. We are finding the magnitude for this only. Okay. So now what happens? A is equal to what is the slope from omega C1 to omega C2? The slope is minus 40. So it is minus 40 into log of what is omega C2 we have taken? It is 10. What is omega C1? It is 2.5. First do this bracket, then add it with A. What is the A at here over here? Omega C1, it is 12. First do this up. Make it this in the calculator first, then add it with 12.
Minus 12.
Minus 12. Answer is minus 12 dB. Yeah, it's correct. And next, what I have to do when omega is equal to omega h. For all the omega we are doing it. Okay. So omega is equal to omega h. What are the omega h we have taken? It is 100 radians per second. One more frequency flow changes is going on here. That is the next step. The next step, if I am doing it for omega h, okay, how it will be? We will be doing it with minus 60 something with the omega h frequency, right? So the same formula will be for higher frequency also. That is A is equal to slope from where to where? Slope is going to
Minus
from omega C2 to it is going towards omega h into log of who is the higher frequency omega h divided by omega C2 plus the magnitude at omega C2, the previous magnitude. Okay, so if we substitute here, what would be the slope from minus C2 to omega h? Omega C2 to omega h, the formula is minus 60. So it will substitute as minus 60 into what is log of omega C2? What is omega h? What it is? 100 divided by omega C2. What it is? 10. We do this bracket first in the calculator. Then add it with here it is formula. Okay. Add it with what is the previous thing we have achieved? Minus 12. Solve it. Tell me the answer.
minus 72.
It is minus 72. Correct. Okay. It is minus 72. To solve up to this, then we will tell you the graph of the dot. Now we will compare the frequencies. That is omega L, omega C1,
Omega
C2, and for omega H. What is your omega in the Gaussian is 0.1. So omega C1 the value is 2.5. C2 value is 10. And for omega H we have Gaussian is 100. Okay. And we find out the magnitude. A is 0.1 for what? How many?
40 decibel.
It is 40. And for 2.5 it is
12 decibel.
12. That is plus 12. Okay. And for omega C2 it is
Minus
minus 2. And for 100 it is we have
minus 72.
minus 72. So now you have to take your similar graph sheet. Okay. The first mark it as 0.1. Okay. So next you will be seeing the points as 1, 2, 3, 4, 5. Okay. The next line will be if 1.5 into 10 will become 1. The next line, the next will be also 1, 2, 3, 4, 5, 6, 10 lines will be there. 1 into 10 will become 10. Okay, that's how we will be marking of the similar graph. And in the left hand side we will be marking the value of magnitude. Okay, maximum magnitude how much we have got here? 72. So we are here maximum we get plus this plus 40. So start from here plus 40. Okay, the next line take it as 30. Next line 20. Next line 10. Next line
0.
0. Okay, so mark up to how many means 80. Okay, if it is not coming the actual 80 means what we have to do? We have to take in the scale of 20. That is 40, 20, again it is 0, again here is minus 20, minus 40, minus 60, minus 80. Okay, now shall we draw the graph? So when omega C is 0.1, what is the magnitude? It is 40. So you have to mark it over here. Likewise, when omega C1 is 2.5. 2.5 is the next step. After 1, it will be 2. The center part of this will be 2.5. In 2.5, what is here it is? Magnitude is 12. 12 means over here. 10, 12.
Minus
Plus 12. What I am asking for this 2.5. 2.5 is plus 12. Plus 12 means above 0. Okay, which is over this side and here. Okay, this point will be the point for next. Okay, next one. Next omega C2. Omega C2 is how much? 10. So into 10. What is the value? Minus 12. Below 0. Below 0 the limit is 10. The next line is minus 12. So here this will be the third point. Okay, likewise for the next 10 point is 100. For 100, what is the magnitude? Minus 72. Minus 72 means the mid of 60 and 80 is 70. The next line is 72. So just keep your scale here and mark it as here. So your magnitude plot will be this. Okay, clear to this? So you have to mark this in your graph sheet. Take your similar graph sheet and mark it. So what I call that is all about magnitude plot. Okay, next what we are going to plot it, we have to plot it the phase angle. Okay, so for phase angle you will be marking of angle of j omega for the quotient, that is 10 divided by j omega into 1 plus 0.4 j omega into 1 plus 0.1 j omega. Okay, and for now listen. For prediction, we will do it. In the previous problem, the numerator there is a s square. Okay, so if it is s square, it means for s what it will means? For s it is 90 degree. Correct? S domain, how much degree? 90 degree. Then for s square it will be 180 degree. Okay, so if it is 1 by s means it will be minus 90 degree. Okay, 1 by s square means it will be minus 180 degree. Okay, that is how you will be making the phase plot phi formula. Phi is equal to, here in our question what it is here? 1 by s.
Yes.
10 by j omega. Just 1 by s. Okay, so the first term is this 10 by j omega. Whatever it is, the s is in the denominator. So the angle should be minus 90 degree. Okay, next term. It is 1 divided by 1 plus 0.4 j omega, right? We will be writing it as this is in the form of a plus b. Here it is a single term s, so we can say it as minus 90 degree. If it is like this, means the slope will be like, it will be like this, right? It will be like this. One of the side is a, other side of it is b, means we will be taking it as tan inverse of b by a, correct? Mathematical form. So the same thing we are going to apply here. That is for here it is 1 plus 0.4 j omega. What it is? In place here it is a plus. Then in formula it will be minus. Okay, minus tan inverse of b by or you can say that minus tan inverse of minus 4. A is what? 1 only. 4 by 4 it will become minus 0.4 only. Okay, sorry, this 4. 0.4 by 1 will become 0.4 only. One more thing is there. What it is?
J omega.
J omega. Okay, omega. Next, the other term will be minus tan inverse of where it is 0.1 omega. That is all. Next, what we have to do? We have to substitute. What we know? Omega L is 0.1. What we know? Omega C1 is 2.5. And what we know? Omega C0 is 10. And omega H is 100. In between also some of the omega value you can take it for the mean phase diagram. Okay, so we can take that here. Omega as more than 0.5 we can take it as 1, and then we can have one more omega we can take it as 3, and then one more omega, we can take it as a 50. Just to substitute in place of omega. That is, for these varieties of omega value, what is the value of phi? Just to substitute minus 90 minus tan inverse of 0.4 into the first omega is 0.1 minus, clear what I am doing, minus tan inverse of 0.1 into what is omega? 0.1. If I substitute, I will be getting a value of 5. Likewise, I have second time I have assumed omega as 1. The same I am going to repeat it. What is the value for here? Minus 90 minus tan inverse of 0.4 into 0.1 minus tan inverse of 0.4 into 0.1 into 0.6.
Minus 90.
Minus
93.
90 minus 93 okay, is equal to minus 93. What value comes? That is your phase angle. Next, substitute in place of omega, substitute 1. Just to change this alone. No need to delete everything. Okay, just to go back, press the left arrow. Okay, in your calculator, just press the left arrow and change that point 1 into 1. What is the value of 5?
Minus 24.
Minus?
22.
No, should be greater than minus 93. Check it out. Minus 90 minus tan inverse of 0.4 into 1 minus tan inverse of 0.1 into 1. It will be greater than minus 93. Okay. Shall I do it in the calculator? So, when you are substituting this omega as 1, we will be getting minus 121. Again, when I substitute this omega as in place of 1, we have to next substitute the 2.5. If I will substitute that, in place of 1, substitute 2.5. What is the value? It should be greater than 121.
Minus 155.5.
Minus 155. Okay. So next step. We have to do it simultaneously. For omega is 3, listen. So we have to do it. For omega is 3, what is the 5 value? For omega is for 10, what is the 5 value? When omega is 50, what is the 5 value? Omega is 100, what is the 5 value? Okay. After calculating this, now we are having the omega frequency with respect to phase angle. The same we are going to plot it in the graph. In the graph, we are having the omega in the x-axis. Okay, over here we will be marking it as 0.1. Here in this graph, we have marked this as 0.1. If this is 0.1, this is also 0.1. So, okay, log of omega is in your x-axis. Here is also 1 means here is also 1. There is no change. Okay, here it is also 10 means 10. Here it is also 100 means here is also 100. Okay. In magnitude, we will be taking it as here. In this axis, we have taken it as magnitude. We have marked as plus 40, 30, 20, 10 up to 80, minus 80 we have marked the. And that we mark the phase means towards this right hand side. Okay, so maximum substitute that the omega which is equal to 100, we will be getting the maximum frequency as minus 262. Okay, and I will substitute this omega equal to 100 over this formula. I will be getting minus 262. So take this as minus 270 to the lowest, and here minus 260, minus 250. Likewise, you take up to 90. That is up to minus 90. Okay, so shall we draw? I know the omega value. For 0.1, what is the frequency? Minus 93 will be like this. And for 1, what will be? Minus 121 will be around here. Okay, if you plot it, then that will be about your phase angle. Okay, do it, I will guide you. Now we have drawn this magnitude plot as well as phase plot. Okay, so both are what is done. We have to find what? Gain crossover frequency, phase crossover frequency. That is the question. Okay. So Bode curve is to construct the Bode curve in order to find out the gain crossover frequency, phase crossover frequency. What is how will we find out the gain crossover frequency means? Let's draw a straight line from zero. Okay, let's draw a straight line from zero where it cuts in the magnitude plot. That point, then we have to mark the straight line over the frequency axis. This point is said to be your gain crossover frequency. Clear? From zero, draw a straight line in your magnitude plot. Then draw a straight line towards the frequency. That frequency is your gain crossover frequency. For phase plot, minus 180 degree, 180 degree, minus 180 degree. Draw a straight line from minus 180 degree. It will cut in your phase plot at that place. Then draw a straight line towards the frequency. Okay, that frequency is said to be phase crossover frequency. Right. Okay, omega is phase crossover frequency. Clear? For gain crossover frequency, you are drawing line from the magnitude 0, taking a straight line, perpendicular line towards the frequency, and frequency is said to be gain crossover frequency. In the phase plot for the phase crossover frequency, I am drawing a line straight from minus 180 degree. Minus 180 degree, draw a straight line, it will cut in the phase plot. Then I will take drawing a perpendicular line towards the frequency. That frequency is said to be phase crossover frequency. Okay, that is all about it.